Hi everyone, so you started the horizontal controls. They're a little complicated, so I thought I'd put together a video so you could kind of walk you through the logic of it. So when you use the controller, the idea here is that the left joystick here is going to push the robot straight forward, and then when you veer off to the right, the robot will veer off to the right, veer off to the left, straight back, robot back straight up, and then the back turns as well. So that's that one. And then the other right joystick, we're just going to use this white. We've already done this already, just for, you know, go up, go down, or vice versa, depending on how you have the GPIO set up. All right, so the question is now, what do we want to have happen to our left and right motors? So most of you are using a two-motor design in the front to move you forward, at least, a left and a right horizontal. So when we push forward, we want the left and right horizontal motors to be the same speed and both positive, so forward. So up here I'm going to write in that we want a positive left motor, and that needs to be equal to the positive right motor. So those two things need to be true for this to work. And this one off to the right here. So this is when we start turning to the right. So to turn to the right, we need the left motor to be faster than the right motor, because this one's going to spin and pull us ahead of the right motor. In fact, the right motor could even be negative. We wouldn't really care. As long as it's slower than the left motor, we're good. So here, but we want the left motor to be forward because we want it to still be moving forward as we're doing this. So here we're going to hit a positive left motor on this one, and that has to be greater than the right motor. So remember, you always turn towards the slow motor. So yeah, in this case, you'd be turning right here. Now this one, we push all the way to the right, we don't want to be moving forward. We want to just pivot. And to make that happen, we've got to have our left motor be forward and our right motor backwards. That way one goes this way, one goes that way. And they'll just pivot if they're the same speed. So I'm going to say here that the left motor has to be positive and equal to the negative right motor. So here when we say equals, we mean the size of the numbers. So they should be the same size of numbers, just the left one should be positive, the right one should be negative. Let's see if we can make that happen. And then the final thing here, oh, down here we want to be the same as this one but backwards. So they have to be equal and both negative. So down here I'm going to say negative LM has to be equal to the negative RM. All right. Now on this one, so let's go up to this one instead. So this is where we're pushing forward and then we start going to the left some. We want our robot to go to the left, so we want our left motor to be slow and our right motor to be fast so it gets out in front of us. So here we want the left motor to be less than the right motor, and we want our right motor to be positive. That's the one that's going to be dragging us forward. If the left goes a little negative, we don't even care about that. That's totally fine. As long as the right is still forward, we should still be able to move forward some. Okay, and then this last one here is the opposite of this one. So in order to pivot and turn left, the right motor has to be bigger than the left motor, so it has to be positive. So here we're going to say negative left motor is equal to a positive right motor. And we want those values to be the same. So if the left motor is negative 2,000, we want the right motor to be positive 2,000. They want equal to each other but opposite in sign. That way they're pivoting and not moving forward or moving backwards. Now, you might be wondering why we're not doing these two quadrants. These quadrants, like the logic of them, are really complicated. I didn't think it was worth doing in this video. All right, so that's our general layout. We need to find a way to combine the Y values from the controller and the X values, to put those together to deliver us these two motor speeds. It's not simple, but it's not actually that hard either. Hang in there for the next video.